So we have these three right-hand rules that allow us to kind of figure out the direction of a magnetic field. One is you grab the wire where the current is going through with your thumb pointing the same direction as the current, and the way your fingers turn is the direction of the magnetic field. Magnetic field goes that way, just like these lines are shown here. Now the second one kind of shows you which way the magnetic field is in a coil. So you curl your fingers in the direction of the current in this case, okay? And where your thumb points with the direction of the magnetic field. So if the current is going up this way, like this, that means that you are going to grab the wire like that, and your thumb, this would be the North Pole, and that would end up being the South Pole. The third right-hand rule talks about how does the force act on a particle, like a positive particle. If it were going through a magnetic field, what happens? The electric field is pretty easy. The positive charge will get pulled towards the negative pole. But in this case, with a magnetic field, you realize that the force is only going to be applied on an object if two conditions exist. The object must be moving. It has to have a velocity, so it must be moving through the magnetic field. And two, the force on it will be in the third dimension. So meaning, if you run your fingers in the direction of the current, and then in the direction of the current, so your fingers run in the direction of the current, then you turn your fingers in the direction of the magnetic field. So this is the direction the particle was going. This is the direction the magnetic field was going. And where your thumb points is the direction of the force. So the particle going this way on the magnetic field will get a force upwards and kind of climb up that way. I don't need you guys to be able to determine this, but I just want to show you that these are these cool little rules that exist that tells you which way the direction of the field will be, or the direction of the force will be in that. So our first one is telling you the direction of the magnetic field. The second one also gives the direction of the magnetic field. The third one gives the direction of the force, okay? And so that would allow you to figure these type of things out. We don't need to do this, so I'm going to skip right past all of this. Here's one that you do need to see. This would be using the second right-hand rule. If I curl my fingers on this particular thing, if you're looking at it, you take your fingers in that way, because that's the direction of the current. If you do that, the direction of my thumb would point here, and that would be the direction of the magnetic field. Okay. The same thing here. It would be the opposite. I would be taking my hand in this way to go in the direction of the current, and my thumb would point to the right, and the magnetic field would be to the right in this case. Here's an interesting phenomena. This is how we make an electromagnet. If you take a wire and you wrap it around a piece of iron and pass current through it, you will create a magnetic field. And of course, if you dig the direction of the current, then you can see that the magnetic field would be to the north. These guys are showing electron flow. When they're showing electron flow, you just use your left hand. When they show positive flow, use your right hand. Okay. Here again, they're showing electron flow, so you'd be using your left hand to do that one. So you see how you make an electromagnet. It's pretty simple. You take a wire and you just wrap it around. You put a metal inside it. You get a much stronger magnetic field. If you don't, you get a very weak magnetic field. Okay? The magnetic field, again, is being caused because of the moving charges. Electromagnets have a lot of uses. You've seen them in junkyards where they pick up all the iron or cobalt or nickel objects. Here's a simple way to take a nail, wrap wire around it, put a battery through it, and this should become a little magnet. You should be able to pick up paper clips and stuff with it and kind of create your own little electromagnet, and maybe you guys could try this at home. Speakers work in the same way. They're also electromagnets. As the current goes back and forth, it pulls this thing back and forth, and you will find because of the force on it, and that causes the diaphragm to move and causes air pressure waves, which we see as sound. Galvanometer is simply a device